and Assalamualaikum. My name is Nazalina binti Akarudin. I am the representative for my team members. My team members is Ahmad Akil, Muhammad Ami Isai, and Muhammad Fikri. So we're gonna demonstrate you on how to work on the Raspberry Pi in virtual. So first thing first, you need to download the VirtualBox. And then after install the VirtualBox in your computer, you need to download the file, pixel file. Then it will appear on your desktop, the VirtualBox and the pixels. And then you need to open the VirtualBox. You need to click new, and then you put the name for your OS, and then you choose Linux, and then you choose Debian 32 bits, and then you next it's the size. Next you will create a new. Next you choose the virtual disk image, and then dynamically, and then you will choose the folder, and then you have the OS on your VirtualBox, and then you need to click on that, choose the code, and then you will choose the pixel.iso. After doing that, you need to click start. After you click the start, it will appear the Raspberry Pi virtuals. After the screen is appear, it means that you are successfully installed the virtual Raspberry Pi on your desktop. And then you need to open the terminals, copy the widget HTTP IoT SME, and then you will see the folder that contain in IoT SME zip files, and then you need to unzip that file. After you unzip, you need to open the document, and then you will see the document that you have unzipped on this desktop. That's all for the section A. I will move on for the section B.
Hello, my name is Ahmad Akil. Now I will be talking about section B for the assignment. So in this section, we'll be talking about the booting process of the Raspberry Pi. Okay, first, when the power is turned on, then at first the GPU only the GPU turns on. The CPU will still be off, and then the GPU will execute the first stage of the bootloader, which is from the ROM. The ROM can be an SD card, a pen drive, or any type of SSD or hard drive. And then the first stage bootloader will read the bootcode.bin, which is a binary file, which is the second stage bootloader. It will be loaded into the L2 cache, and it will be executed. And then the second stage bootloader, the bootcode bin will turn the SD RAM on, and the third stage bootloader, the loader bin, will be started. The loader bin will then read the GPU's firmware, which is called the start.elf, and then the start.elf will then read the system configuration parameters, which are configuration.txt, cmdline.txt, and kernel.img. Only then will the OS start. Okay, that concludes part B.
Hello, my name is Muhammad Fikri, and this is the video for the virtual memory statistic, or the VMstat, for the Raspberry Pi in VirtualBox. So here, as you can see, the Windows resolution is not that comfortable to see or use. So let's change the resolution using the command xranr. And from this available resolution, I will be choosing this one, the 1920 times 1440. So xranr -s 1920 times 1440, and as you can see, the windows has expanded, and much more easier to be used. So here we can use the command vmstat dash dash h to see the available command. So we can use these options, added to the interval or delay and the count. So for this video, I will not using any count so that the vmstat will run continuously. But I will add the command dash n to avoid any repeated header, and we use the 3-second interval. So as you can see, we have the header here. We have the from this one, we have the process that are currently waiting, the process that are asleep, swap, and the free space, the buffer, the cache for the memory, and the swap is currently swap in and the swap out is 0. We are not using it. And we have the block that is currently being read and written in the IO. So here we have the only the initial one that is changes, because this is from the terminal, and after that it will be 0. I mean, this is from using the vmstat. Yeah, this is from using the vmstat. So and then we have the system, the in and the cs, which is the in is the number of interrupt and the contact switches, and then we have the us, sy, id, wa, and st for the cpu. So this is for the non-kernel, the kernel process, and the id is the idle, and the wa is the waiting for the io operation. So basically idle, currently the this one we have idle because we are not using the vmstat, and after we use the vmstat the idle is 0. This is also because of the interval and all. Maybe I'm wrong. So from there, let's just use this. From the section E, we can use the building simple circuit coding to see any changes occur in the vmstat. So let's run. Sorry. Yeah, let's run that. And then as you can see, let's click on the GPIO 15. So here we can see instantaneous changes there for the R, for the free memory, the cache, and the buffer, and also all from the CPU and the IO. Let's click another one there. So here you can see there are some changes that are occurring, especially, and here for the idle we have a bit of idle, and then again it goes back to 0. Let's click another one, GPIO number 24, and there you go, another changes. And lastly, let's try GPIO 26, and there you go, another changes. These changes will affect differently up to the coding. We choose whether they use many memory or they use the CPU a lot or not. So it's based on that. So as you can see, the coding for the number 26 is a lot, so it use a lot of the memory and also the other. So that is all from me. Thank you.
Next, I will move on to the section D, Programming GPIO in Hardware Pi. For this part, first thing first, you need to check the Python version that installed in this hardware by using this command, Python. It will show that the version that you use is Python 2.7.9 version. So next, you need to update and upgrade the Raspberry Pi hardware by using sudo apt-get update and sudo apt-get upgrade. After done installing all the package, you need to install the GPIO in this hardware because you are first time using this hardware with the GPIO. By using sudo apt-get install RPi.GPIO. After you have done install all the package, you need to open the nano file and import RPi as GPIO. And then you need to set mode by using GPIO.setMode GPIO board. Then you need to set up by using GPIO.setup 12 as GPIO out. Next, after you done setup, you save that nano file. After you have done save the nano file, you run this GPIO read all to know the GPIO for this hardware. But in my case, this error is occur. Unable to detect the module. So, for this part, we need to install the wiring by using widget HTTP wiring. So after you have installed the wiring, it will show you the hardware that we are using. As my case, I'm using Raspberry Pi 4. So that after you have done know the modules and this Raspberry Pi know the module, then you run back the GPIO read all. Then it will show all the GPIO that is used can be used in this hardware. That's all.
Hello, my name is Muhammad Amir Isaid bin Ahmad Kamal. This is assignment for section E. Okay, this is the coding that are shown in the assignment document. So we will run it within the Python 3.4.2. So right now I will run the module, or we can just click F5 to run the module, to run the code also. Okay, and then right now the module already run, and then I will enlarge the module GPIO emulator. So based on the coding, we can see that here when GPIO 23 turn false, it will increase GPIO 4 to high and GPIO 17 to high also. So right now we need to know that for the false and true, true is 1 and false is 0, and what is high and what is low. So for high, it is the red marker, red color, and for the low, it will be the green color. So right now we can see that all GPIO 4 right here, it is output 0. So it is low and it is green color. And GPIO 18 here, GPIO 17, and also GPIO 21 here. So when we change GPIO 23 to 0, so right now GPIO 23 is actually 1. So when I click this one, it will turn the GPIO 4 and GPIO 17 into a red color. So right now we can see GPIO 4 and GPIO 17 turn out to be high, 1, and it also a red color. So we can try what happened when we click on GPIO 15, which is to make it high or true. So right now GPIO 15 is 0, which is false. So when I click it, it will turn true, and then it will turn false again. But when the GPIO 15 detect that they are true, it will change 18 and then 21 to high. So right now we can see that 18 here is actually red color, and the 21 also red color, which is the input, the reading that we can detect here is actually 1, which is high. And then we can try it with 24. So right now when we when we click 24 here, 18 and 21 will turn low, so it will become green again. So when we click here, here you see, uh, 18 turn 0 and 21 turn 0, and it's also the same with 26, which will change the GPIO 4 and GPIO 17 into low, which is 0. So right now it is a green color. So that's all for me. Thank you.
Hello. Now I will be talking about section F, which is about the internet on the Raspberry Pi. So on the Raspberry Pi, you can either connect to the internet either using Wi-Fi or the Ethernet connection, which is the wired connection. If you are using the wired connection, if you would want to see the information about the current Ethernet connection, you can just type out the command if config space eth0 and press enter. Now you can see the information of the current Ethernet connection. And if for some reason you would want to turn off Ethernet, but without physically uh, taking off the wire, you can just do that by turning off the port itself by using the command ifconfig sudo ifconfig eth0 space the word down. Now if you click there, if you see up there, up on the right, the signal bar is now there are two X there, so that indicates that the Ethernet connection is severed. So if you want to turn it back on, you can just rewrite the same command but change the word down to the word up. And now if you see on the top right, the signal bar is moving again. That signals that the Ethernet connection is back on. I think that is all for section F. Thank you.